And now it's time to talk about walls. So in the southwestern United States, walls are everywhere, and they're not just slatted fences or anything. They're typically concrete walls, and sometimes they might have like weeping holes in the bottom or pressure holes or scuppers or things like that. But in general, they typically do change the movement of water on the floodplain because they're concrete walls and they can collapse under pressure. So if the water gets too deep on them, they can collapse. So the Flood Control District of Maricopa County uses walls and generates wall lines, and they provide these for their clients. If you right click now, then what the client is to do is to decide which of the walls are hydraulically significant and remove the rest. And so I've kind of done that in this by removing a lot of walls that represent, in walls that are inside big neighborhoods and things like that. I've gotten rid of those. And then I right click the layer, open the attribute table, and these are the attributes that you need. You don't need FID. In this case, instead of using the correction field, I'm going to use a field called wall height. So I'm not going to use the crest elevation, and I'm not going to use a correction. I'm going to use null elevation and wall height to set up my walls. So we will ignore mixed elevation and mixed height, and we will ignore elevation and correction. And we'll ignore fail elevation because we're going to apply fail depth. And these other failure rates, because walls collapse, they are all set to 0. Okay, so let's close this and let's open the levee and wall tool. So that is, I think it's this guy. Yep, levee and wall tool. And this says add walls to your user levee lines. So all it's going to do is copy the walls from here into the user levee lines. So we need to set up the crest elevation. Remember, I was going to use a null value for that. And then for the name, that was also null, so it'll probably make its own names if it wants to. The FID, the correction field is going to be set to wall height. That's important. So this one is null. It doesn't have any data in it, and this one has 6 feet wall height in it. And then we'll set it up to provide the failure for these walls. Okay, so this will be, and we want to use failure depth. So this becomes failure depth, which was 2 feet. And the rest of these can be set to their respective fields, but remember, those were all blank. So if you wanted to just set them all to a null field, that would be perfectly fine. Or a 0 field, not a null field. It would be a 0 field. Okay, maximum width, fail rate, because they collapse. They only collapse. This will be the vertical rate, and this would be the horizontal rate. And those were all zeros. Then we click add the walls, and that is finished. So we're finished with those, so I will uncheck them. And then let's go take a look at our levees. So these are our levee lines. You see, all I did was copy the walls into here. And it's a lot cleaner data. See, you only have the data that you want, and it did give it a unique name, and it does have a null elevation and a 6-foot correction. And now we will run the calculator that turns the levees into walls. So that's back here in our levee tool, and we only have levee lines right now at this point, so we click create schematic layers from the user levee layers. And this tool can be additive, or it can just create new layers. You can add to what you currently have, or you can create new. Now whenever you have some redundant levees, it's going to ask if you want to delete them, and you can just click yes. There's only one, it looked like, in this one. And now there are this many levees, and this many of our levees have assigned failure data to them. So I click OK, and now I think I want to, let's see, turn on the switch, right click, set the control parameters, and then we need to turn on the levee switch and click save. And then we can export the walls and review the wall data. So that is here, export dot files. We'll just put them right in here. And this time we already have reduction factors in there. So this time we'll just put our levees in there. and then we go to our our test export folder, and we can, oops, we don't need that one. We can open these two. That ARF is already open, and you see that we have cont.dat. We now have channels, levees, ARF, WRF, rain, infiltration, storm drain, hydraulic structures. And levee.dat is not, oh, I messed up. I forgot a step. Hang on, sorry, I forgot one step. We need to go to the levee editor and check prescribed failure, and then export that data again. Just the levees. Okay, and if I go back here and I click to reload the data, you'll see that this has now been turned into a 1, meaning that that is prescribed failure and it's going to be using wall collapse. So this line represents a single grid element, and these are the wall cutoff directions and the failure elevation, or sorry, no, this is the crest elevation of the wall. And then these guys down here are the failures set up for the wall. So this would be this grid element, or sorry, excuse me, this grid element has the levee here in direction 6 and 3, and it has a fail elevation that is 2 feet higher than the grid elevation of the wall. And it's 2 feet, it'll be 2 feet higher than the highest of the 2 grid elevations in this cutoff direction. So that's how these work. So if we copy one of these and we go back to QGIS real quick, we can put this in here, and then we can zoom to that. And then you can see that that is 1406.5. And let's see, what are those 2 failure directions? And this one is, whoops, let me grab this button here. So it looks like we're talking about the directions were 6 and 3 in this grid element. So this is 1406.5. So if you added 2 feet to that, it would be 1408.5. And this is 1406.9, so if you added 2 feet to that, it'd be 1407.9. So this one would be probably, this fail elevation would probably be 1407.9. Let's see if that's correct. Oh no, 1408.9. Sorry, that was 1406.9. Not sorry. So I miscalculated. So it should be 1406.9 plus 2 is 1408.9. And then this one was, let's check that one. That one is 1409.792. So that one becomes, let's see, that's 1407.792. So see, it takes the higher of the 2 elevations and adds 2 feet to that to create the fail elevation. And that is how you set up walls and wall failure. So I think that's the end of the video, and I think the next one will be to save, export, and run.